What is going on, guys? Welcome to your 19th video, and in this video I want to start talking to you guys about the conservation of momentum and energy. Now, the first thing I want to do is give you guys a definition for momentum because I don't think I defined it before. If you go ahead and look on Google or your textbook, they'll say something like the force of movement, and that really doesn't make sense, the force of movement. So my definition is the force that keeps stuff moving. Okay, what exactly do I mean by that? Well, let's go ahead and say that you had your arm right here, and let me try to draw a hand. Oh, that's a pretty good looking hand. Now, what you're doing is you're throwing a baseball. Let me just draw a quick little baseball, and you're whipping it through the air as hard as you can. Well, obviously, the baseball is the object that we're talking about, and the force that moves this or is causing it to accelerate is your hand. But if someone took a picture of it when it was in midair, you would notice that this force is no longer applied to this baseball. Of course, you threw it before and you were touching it, but as it's in midair, even though the force isn't directly applied to this ball, the ball continues to move and move and move even without the force being applied to it. So the reason that this ball keeps moving is, of course, the dumb answer is, of course, you threw it, but the technical physics answer is because this object has momentum. Now, the formula for momentum, in it's better to write out this entire formula because you have two things with the letter M, is mass times velocity. So, since mass and velocity are directly related to momentum, the faster and more massive an object is, the harder it would be to stop. So basically, let's go ahead and take two objects with the same velocity traveling at the same rate of speed. A baseball and a bowling ball. Even if both of these were traveling at a velocity of like 3 meters per second, the bowling ball would be harder to stop because it was more massive. Now, say that you had two of the same objects, two baseballs. Well, baseball A was traveling at, 80 meters per second, and baseball B was traveling at 10 meters per second. Well, of course, baseball A would be harder to stop because it has a faster velocity. So that's all momentum is. It's really an obvious word, but they decided they needed to put a vocabulary word on it to, I don't know, just to complicate your life a little bit more. So in the next tutorial, what I'm going to do is I'm going to show you guys an example of the conservation of momentum, and it's a really cool and probably the most famous example in physics. So you definitely don't want to miss it, and I would do in this tutorial, but I spent all my time talking, rambling on, so I'll see you next time.